Hello and welcome, ladies and gentlemen, for a new video about writing bash scripts and refactoring them. It's the fourth video, I think, in my series to write bash scripts. So if you didn't see the other videos, I invite you to watch them for you to understand what's going on. Just to remind you, we were writing a bash script to back up different files from one directory source to one directory destination. So here I have a directory source and destination, and if I look at them, I have a bunch of files and folders and directories in source and nothing in destination. So the goal of the script is simply to back up everything from the directory source to the directory destination to have a file tree which mirror itself each other. So everything I'm doing in source, if I run the script, everything will be mirrored in the directory destination. So we can look at source and destination again, and you can see it's exactly the same in both directories. Great. So let's look at the script again. The last time we were dividing the script in different functions to see more clearly what was happening in there, and trying to separate concerns of our scripts to have better readability and to understand quicker what the script is about. For example, if somebody wants to look at the script and modify it for him or her to understand what's happening in there. So we did that. Now what I want to do with this script is to unit test it. So why is that? Most of the time developers write automatic tests for other languages and for their code bases when they write software in, I don't know, other more modern programming languages. But I rarely see unit tests and automated tests in general with bash scripts. And I'm not better in that, but I think we should definitely do it because bash scripts, first of all, are full of traps. The language itself we use is not that good in the sense that it's very easy to make mistakes and to create bugs. Because bash is not easy to write and there is many things we can get wrong. Second of all, it's good to write unit tests just for other developers who look at our scripts to understand what they're doing, what's happening, how they should work. So I really think we should write more unit tests for bash scripts, and we won't do that in this video, but we will prepare a bit the script for writing good unit tests. Because right now, the script doesn't really work as we really want it to. First, because if you remember, just a quick remember, first of all, we run in this script the function which is called run, which is this one. And here, we call handle arguments, which is another function here. And here we handle our arguments. We pass directly from our script call. So we verify what arguments the script was called with, and then we do different things depending on the argument. Now the problem with creating a function around script's argument like that is that, well, it's now in a new scope because, well, we created a function, and creating a function creates a new scope. So, for example, the async option here doesn't really work anymore. I mean, it works because of the, because we create here async and then we pass it. I mean, we don't pass it explicitly to handle arguments, but handle arguments modify it anyway if we give the dry run option to our script. But this shift here doesn't really work because since we are in a new scope, the parameters given to the scripts are not affected by the shift, because if you remember, this shift allows us to just delete from the list of arguments we give to our script all the options which are listed here, like help, version, and dry run, which means that when we go through handle arguments, normally in the parameters given to the script, there shouldn't be dry run anymore, or version, or help, depending on what we gave. But it doesn't work because since the arguments were given to run, the parameters of the script were given to run with this special variable. And then it goes in this scope, and then those arguments are passed to handle arguments, and we delete from this list of arguments all the arguments we let's say manage with handle arguments. But in the scope of run, we still have all arguments, which means that if I do, for example, if I echo the first parameters of the script, and if I do that and -d, well, it didn't work because I didn't save. You see that the first argument is still -d, even if, because of the shift here, it shouldn't be. -d should have been kicked out from the list of arguments. So how can we do that? I mean, what we can do is to return the list of arguments from handle arguments, and then use these arguments afterwards. In our case, it's not really a problem because we never have arguments after the list of options we give to the script. But if we had, well, we would need to somehow shift these options. And why we need to shift these options? Because we have a problem here. If we want to do unit test, it would be easy to test for the option we give, like dry run or version or help, because we just have in our unit test to call our script like that, backup.sh with -d, and see what happens. And then we can parse the output and see if there is a dry run string, for example, in the output. So it would be easy to test that. The same if we do -h. The problem is it's not really, I mean, it's interesting to test that, but it would be more interesting to see if really the backup script do what we want it to do, that is, to copy from one specific directory everything to another specific directory and mirror it. Mirror the whole content from one directory to another. And this is made because we have here in hard, directly in our script, hard-coded, the directory which is a source and the directory which is a destination. And if we wanted to write a unit test for that, it wouldn't be flexible because we would always need to have a source directory and a destination directory, and it would work like that. And it's not practical. I mean, if we want to, I don't know, test different directories and we want to give as input to the script those different directories, we can't do that here. So basically what we want to do is giving those directories to the script. Like that. Let's say, I don't know, source equal source, destination equal destination. We could do that, for example. We won't do it like that, but we could do that. And then, since we give that directly as input, well, it would work. And it would be something like that. But if we want to do that, we need to, and let's say we have options before, we need to kick out the options before, managing the different arguments of the script, as we saw in the first or second video. So basically, what we could do is get the parameters directly from the handle arguments function, right? And we could return from the argument function, well, every parameters, like something like this. So we could do return like that, but it doesn't work in Bash, of course, because return is only for the return code. That is a number from 0 to 254, if I remember right. To just say, hey, this was basically good, nothing happened, or this is an error. Yes, 0 means everything is good. But we don't want a return code. What we want is to return an array, basically, because we want to return all the parameters given to the script minus options we give it, like -d or -v. So how do we do that? The easiest way is to echo directly everything. So we could do echo every parameters, for example, and then we could do that. Params equal, and here what I'm doing is I'm running directly that and putting the function call between parentheses with a dollar in front means that I want to run that, but I want to get whatever was echoed with this command, whatever output of this function. So the output here is given by our echo command. So here I would get the params, and then I could, I don't know, parse them to get the source folder and the destination folder. The problem with that is that when you do this parenthesis with a dollar in front, it means that handle arguments will run in a subshell, which means that our rsync options, which is mutated directly in the handle arguments function, won't be mutated anymore because rsync option is not in the same scope anymore like handle arguments. And it's not even in the same shell, because handle arguments is run as a subshell, that is a process which is the child of the shell you have already running. It won't work. So here we begins to have big headaches how to manage all of that. And at the end of the day, I think what we did the last video to just separate everything into different functions was not a good idea. And it's what I sometimes call premature refactoring, because we didn't really need it to refactor all of that into its one function. It's better because it gives the intent and it separates really well the different things the script is doing, but it makes everything more complicated. So what we can do is taking all of that, putting it directly at the beginning of the function run, and going like that. Now, we don't need, we need to create rsync at the very beginning. So here we create the rsync option, which is an array of parameters given to rsync below in the script. And here with the option dry run, we add to this array dry run for rsync to use the option dry run. So it works. We delete all the option processed, and we can delete that. And now it's better. This line works as expected. That is when we arrive at line here 41. Everything left from the parameters we gave to our script is only every parameters without the options we processed before. So that's great. Now the question is, how do we pass that to our script? So we could do as I was saying here, I don't know, having some parameters, source and destination, and giving what we want, what directory source and what directory destination we want. But I mean, in Bash script, it's difficult to manage between different functions or different scripts maps, because this is a map or an associative array, if you prefer. And this is really complicated to pass from function to function or from script to script. It's better, I think, to directly create a file, and we can parse the file. We give the file as input to our script, and we parse the file. So, for example, what we could do, what we could do is to have a file we could call, I don't know, dir.csv, and in there we would have every source and destination we want to use. So we could have, for example, source2, destination2, and source destination. It means that the first column of our CSV is the source directory, and the second one is the source destination, is a directory for the destination, sorry. And it will go through every line like that and copy from source, everything from source to destination, and copy everything from source to destination too. Okay, so first of all, we need to be sure. First of all, we can delete that now, and we need to be sure that we give the file as input to our script. So we need at least at that point a list of parameters given to the script which is not 0 but greater than 0. So to have the number of parameters we give to a script, we can use this special variable, and we can say if this is equal to 0, in that case we can echo you need to give a file as last argument, and we exit the script, and this time we give the return code 1, which means something happened, there was an error. Remember, if we exit 0, it means everything was fine and there is no error. It could be 1, it could be 2, it could be 3. Everything which is not 0 is an error. So then afterwards, we need to get the file. So here we are sure that we have at least one argument, but we could have, I don't know, 10 arguments. Like for example, I could do backup that, and then I could do, I could give one argument, which is my file, and then I could give 1 million other arguments, which are useless, but still I need to choose from there what do I process. So here we can say that the last argument given to the script is a good one. And to do that, we can create a new local function, local variable, sorry. And we can do that. So this special expansion, parameter expansion, means okay, I want the last argument given to the script. And now we need to parse the file. So before we had a map which was done with a for in loop, but now we need to read a file, and to read a file we can do a while read minus or line do, and then at the end done. And to the done we can give the file like that. So what means while read minus or line do? The minus or, if I remember right, it's to read the file without considering the backslash as a special character. Because without that, if you had a backslash in your file, it would think that it's an escape character. Like, for example, when you want to escape a character which is a meta character, sometimes you use a backslash like that to escape a backslash, for example. Well, we don't want backslash to be used as escape character here. And then we need to somehow, so here so it's a CSV, so I mean it's, yeah. So I just changed the display here for you to understand. So the first line we have, and all the line actually should be separated with a comma. So everything before a comma should be the source directory, and everything after the commas should be the destination directory on each line. So to do that, we can use other expansion trick. So here I read all the file, and each line is represented by the variable line here. So I can create a new variable which is called src for source, and I can do that. So what does it mean? It means that I want everything from the line variable except everything which is after a comma. That's what it means. So if I want everything except the comma and everything after the comma, it will give me this part. I want everything except the comma and after the comma. We want exactly the contrary for destination. So we need to do something like that. So here it means that I want everything except what's before the comma and the comma itself. So we want that, for example. All right. So we have what we need. So then, well, it's like before. If the source is not a directory, well, we throw an error. I mean, at least we echo an error and we continue, which is not very good actually, because we should send that to the standard error output. But I mean, it's good for now. And yeah, here we just run rsync from source to destination. So actually it should work like that. Now what we can do is is to copy source to source 2 and creating a destination 2 directory. Like that, we can really test everything manually for now. So let's look at all of that. Okay. So I need to delete everything which is in destination. Didn't do that. Okay. So here we see that in destination and destination 2, there is nothing. In source and source 2, there is a bunch of file. To differentiate source and source 2, I could delete some stuff. Like, for example, I could delete in source 2 my file, my folder. Sorry. Could delete source 2, my file, source 2, my folder, my file. Yes, I want to delete all of that. So So here I have, I have different sources and destination which are empty. So let's try the script now. So let's try the script without anything first. What happened? You need to give a file as last argument. Yep. So it works. Let's say I give an option. Well, it does the same because I always need the file as last argument. So let's give the file and let's do a dry run to see what happens. And it looks like it works. First we do dry run, as you can see here. So it means that nothing was really created or deleted, or nothing happened really. Just we want to verify that the output is a good one to be sure that everything is working. So apparently it copies everything from source 1 to destination, from source to destination, and from source 2 to destination 2, which looks very good actually. So let's do it without the dry run. And let's look at our different source and destination. And it looks like it worked well. Destination 2 is exactly like source 2. Destination is exactly like source. It's exactly what we needed. So everything looks fine. So now we can give to our unit test we will write in the next video any file we want with a list of source and destination directories, and we can test using that. First of all, and second of all, writing automated tests allowed us to see that there was problems in our scripts with our arguments, first of all. And second of all, it makes the script even more flexible because now we can really adapt everything we want to back up, for example, in an external hard disk or whatever, not directly in the script, so we don't have to touch the script and maybe create bugs and errors in there, but just touching the file we give to the script as argument, and from there we can really modify our backups without the risk to and the hassle to go into the script and modify everything. So thanks a lot for watching. I hope you liked it. Don't hesitate to comment for feedback or to show me your love. Thanks a lot. Have a nice day, and see you in a while. Ciao.